Now, um, yesterday we have learned how to, you know, deal problems that, about parallel and non-parallel lines. Again, um, what's the property or what distinct characteristics does two parallel lines has? If you have two parallel lines, again, their gradients are the same, all right? If two lines are parallel, that's true. Now, if two lines are not parallel, we basically just need to solve those two equations simultaneously. So we didn't have any questions about that yesterday because you have learned that even before back in Sec 2. All right. So today we are going to have 7.6 equations of perpendicular lines. So this is the second kind of lines that you're going to encounter in this chapter. Um, let's first define what are perpendicular lines. When you say a line is perpendicular to another line, it basically creates a 90-degree angle on that line. For example, you have here line AC, right? And then you see this line BF. So this line BF is perpendicular to line AC. Likewise, line AC is perpendicular to line BF. All right? Okay, so this is how perpendicular lines look like. They create a 90-degree angle to each other. Okay, now it says here by definition that perpendicular lines gradients, when you multiply those two gradients, the gradient of AC, and then the gradient of line BF will be equal to -1. That is true for all two perpendicular lines. So for example, if AC is perpendicular to BF, and then the gradient of line AC is 5, what do you think is the gradient of line BF? Okay, so again, the product of the two perpendicular lines, the product of their gradients should be equal to -1. So what number or what fraction should we multiply to 5 in order for us to get a -1? Huh? So what's the missing number here? What is the gradient of line BF? That when you multiply this 5 and then the missing gradient, your answer is -1. Okay, so what's that number? Now, if you're looking for that number, always remember this word. You need to get the negative reciprocal of, of, of the other line. What do we mean by negative reciprocal? Now, back in fraction, when we divide fraction, we get the reciprocal of the second term, right? For example, if you multiply 1/2 times, 1/2 divided by 3/4, the thing is you need to flip this, right? Now, that flipping method is called reciprocal. Okay, it becomes 4/3, right? Remember this back in division of fractions? So we do that here. So what is the reciprocal of 5? It's basically what? It's basically 1/1/5, right? There you go. Okay, but take note, it is a negative reciprocal. So it should be -1/5. So from there, so that's the number that you need to look for in the future or in the coming questions. Okay, so when you multiply 5 and -1/5, your answer is -1. That makes the statement true. All right, now we will have examples like this later that shows this property of two perpendicular lines. So let's have one example. Okay, so this one came from exercise 7.6 because there's no question like this in the book. Okay, so I took one question from 7.6. Now, on the first question, it says here, given the points A, B, and C. So A is 3, 7, B is 6, 1, and C is 28. Prove that AB is perpendicular to BC. Now, how can we prove that? Now, we can only prove that when we multiply the gradients of two lines, and then when we get -1 as their product, that's the only way that we can prove that these two lines here are perpendicular. Okay, so how are we going to do that? So first, basically you need to find the gradient of both lines, line AB and line BC. All right, so I took the liberty of answering them right away. So my answer for gradient of AB is -2, right? And then the gradient of BC. By the way, class, I didn't write the formula for gradient because I believe you know the formula already by heart. All right. So anyway, so the gradient of BC is 1/2. All right. So when we multiply 2 and -2 and 1/2, are we going to get -1? Yes, we are going to have -1 when we multiply these two gradients here. Therefore, proving that line AB is perpendicular to line BC. Okay, so that's it. Any question? Okay, maybe someone's asking, Mister, what if I get -2 instead of -1? Of course, that means that they are not perpendicular to each other. The only way that you can prove it is by multiplying their gradients for each of this line, and then your answer should be -1. Okay? Now, if your answer is not -1, that means that they're not perpendicular. Maybe they're parallel or non-parallel lines. I don't know. Okay? But what we're trying to find here is to get -1 as our answer to prove that they are perpendicular. Okay. Now look closely, class. Now, if you compare these two gradients before we go to the next example. Now, if you have -2, is 1/2 the negative reciprocal of -2? Yes, of course, because when you take the reciprocal of 2 or -2, it will become -1/2, right? It's your negative reciprocal. So that's why your answer is positive 1/2 here. Okay, so this is the again, the word is negative reciprocal. Okay, now same goes with 1/2. If you get the reciprocal of 1/2, you will get 2, and the negative reciprocal makes it a -2, which is this one. Okay, it's always vice versa. Okay, but just remember negative reciprocal, okay, of the other gradient. All right, so any question, class, with number 1? Okay, so no question, yeah. All right, now let's have another example. Now this one is from the book, okay? So this is similar with this example. It's just that instead of numbers, we have now expressions, okay? So let's have this one. So the points A, B, and C have coordinates T1, 3, 4, and then 6, T plus 1. All right, so your Y value here is T plus 1, okay, respectively. So this is A, this is B, this is C, right? Show that the line AB is perpendicular to the line BC for all values of T. Okay, so what we're trying to answer here is this, only this. So again, we just need to prove that line AB is perpendicular to line BC. How? Same. So we just need to multiply their gradients and make sure that our answer is -1. Again, if not -1, it's not perpendicular, right? Okay, so first, you take the gradient of both lines, AB and BC. Okay, so line AB, its gradient is this. Okay, let me box that. So the gradient of line AB is 3 over 3 minus T. And then the gradient of line BC is T plus 3 over 3. Okay, so these are the gradients of each line. All right, now again, what we're after here is to get -1 when we multiply this two, right? So that's what we're going to do. So let's multiply this two and this one. Okay, so when we multiply this and this, basically we can cancel 3 and 3, right? However, t plus 3 is not the same as 3 minus t, right? So what should we do first? Now, what I did here is to extract negative 1 from 3 minus t. It's because you want this to be the same as this, right? Now, when you extract negative 1 from here, it will now be similar with t plus 3, and then that's what happened here. Okay, so when you extract negative 1, it's now similar with t plus 3 over here. Okay, so therefore, when you multiply this, basically you can cancel a lot of things, except for this one. Therefore, your answer here is what? Your answer here is negative 1. So again, if your answer is negative 1, that means that the two lines are perpendicular to each other. Okay, so from there, we have proven that line AB is perpendicular with line BC. Okay, so any question, class, for this example? All right, none? Okay. Okay, now let's have our next example. I have three kinds of example here actually, class. The first one, or the first set, is just proving that these two lines will be perpendicular to each other. The second set of examples for today will be about equation of a line. A bit, a bit tricky, but it's manageable. I know you guys can do this. All right, now let's have example number 17. Okay, I'll explain everything here. Now, example number 17, the question is we need to find the equation of a straight line passing through point A, which is 2n, negative 3. And then this line is perpendicular to another line. Y is equal to 3x plus 1. Okay, so can you visualize that, class? So you have two lines here. So the first line is this. So the first line contains point A, right? And then the second line, again, is perpendicular to the line y equals 3x plus 1. So if you imagine this, it should look like this when you draw it. Okay, so this is your line that contains point A, right? And then there's another line which is perpendicular to this line, this one, right? So that's why you have a 90-degree, 90-degree marker here, all right? So this line is the y equals 3x plus 1. So these are your two lines, okay? Now, basically, the question for letter A is you need to find the coordinates of F, of point F, because those two lines, these two lines will intersect at point F. So this is where point F is, okay? So how can we find their intersection point? So first thing that you need to do here, class, is to basically get the equation of this line, right? And then since they are non-parallel lines, so how do you solve two lines that are intersecting? So you can solve this by solving them simultaneously, right? So that's what we're going to do. So to find for the coordinates of F, let me repeat, you need to find the equation of the line first, all right? Of this line, of the first line that has point A, all right? Because point F is along that line, okay? So like this, and then we have F here. So you need to find the equation of this line, right? All right, so we're given here another line, which is y equals 3x plus 1. So from here, what is the gradient of this line? So the gradient of this line is 3, right? Here, there. Okay, now from here, can I get the can I get the gradient of the other line? Yes, of course, because it says here that this line is perpendicular to the line containing point A and F. So therefore, if they are perpendicular to each other, um, I can say that the gradient of the second line is negative 1/3 because of this negative reciprocal. Okay. Now, how do you check? If you multiply 3 and 1/3, will you get negative 1 as your answer? Yes, right? Okay. So that means that this is the correct gradient of the other line. Now, going back to our sketch here, So that means if the gradient of this line is 3, the gradient of the line perpendicular to this is negative 1/3. Always like that. Okay. This is only true for perpendicular lines. All right. So therefore, to get the equation of the second line, you already have your m. You already have your equation. I mean, your gradient, right? Now, using this formula here, okay, so m is already negative 1/3. Now, for the x sub 1 and y sub 1, of course, you're going to use point A for that, right? So giving you 2n negative 3, right? So basically, this is your equation now. So just simplify this, okay, remove all brackets, and then you'll get y equals negative 1/3 x minus 7 over 3. All right? Okay. So that's your answer. That's the equation of the second line. All right? Okay, so that is the equation of the second line. So this one, okay? So this is for the second line, this one. Okay? So now you have now your equations. Now, the question here is what is the coordinates of point F? So basically, class, to solve for this, you just need to solve them simultaneously, either by elimination or substitution. All right? So let's do that. Let's solve them now. Okay. So from here, okay, listen, class. What I did here is to remove the fractions. Okay, how did I remove the fractions? I multiplied the whole equation by 3. It cancels this, but it multiplies y with 3. That's why it became 3y equals negative x minus 7. All right, so this is the equation that I'm going to use to solve for the coordinates of point F. All right, now, so this and this are your two equations. So here I solved this by substitution method. Okay, so I started with this here, and then since y is equal to 3x plus 1, I'm going to substitute y with this, with 3x plus 1. So instead of y, it now becomes 3x plus 1. It came from here. All right, and then equals negative x minus 7. Any question, class, on this part? Okay, so this is by substitution method. So, okay, so simplifying and solving for x. So basically, your x will be equal to negative 1. All right, and then to solve for y, just use this one because this is equal to y. So y is equal to 3x plus 1. Substituting negative 1 for x, y is equal to negative 2. So therefore, the coordinates of point F is at negative 1 and negative 2. All right, that's for letter A. Any question, class? Okay, none? No question? All right. So let's go to letter B. So for letter B, you just need to find the distance of AF, or the length of the line. Basically, as that. Okay. Now, we now have the coordinates of point A and point F. So we can now basically solve for the distance, or the length of line AF. So using the distance formula, and then substituting all these values in the formula, your answer here will be square root of 10 units. So that's your answer for letter B. Okay, so question number 3 is similar to our example. It's just that it's looking for the value of a variable. Okay, so number 3 is like this. Okay, so let me read the question. The line joining point A3 to B, to negative 3, is perpendicular to the line joining point C, which is 10, 1, to B. Find the value of A. So again, you have two lines here, which are perpendicular to each other. So let's say this is line AB, and then this is line BC. So if they're perpendicular, they create a 90-degree angle, right? And then from the property of perpendicular lines, when it comes to their gradient, the gradient of line AB, when multiplied by the gradient of line BC, will produce -1, right? -1. This is true for all perpendicular lines and their gradients. Okay, so what do you need to do here in order for you to find the value of A? So basically, using this property here, you need to get the gradient of each line AB and line BC. So getting the gradient of line AB, you'll get -6 over 2 minus A. Okay, are you guys following? Okay, so I again did not write the formula anymore for gradients. So how did I get this? So this is -3 minus 3, and then this one is 2 minus A. Simplifying that, your answer is -6 over 2 minus A. That's for line AB. How about for line BC? For line BC, so 1 minus 3 came from here. 1 minus, sorry, 1 minus -3. That's why this is 1 plus 3. All right, and then 10 minus 2 came from here. 10 minus 2. So that's how I got 1/2 here. Now again, using this property, I'm going to multiply the gradient of each line. So AB is -6 over 2 minus A, and then BC has 1/2 equals -1. So basically, class, this is your equation to start from. To start solving for A. All right. So yeah, just multiply these fractions. You'll get -6 over 4 minus 2a equals -1. And then of course, shortcut here is just to cross multiply this to -1. So you'll get -4 plus 2a. Okay, following? Okay. And then you bring down -6. And then solving for a is equal to -1. All right. Any question, guys, for number 3? This is your answer. A is equal to -1. All right, so that's it. All right, now for number 5. All right, now number 5, let me read the question again. So find the equation of the straight line passing through point A, which is 4, 5, and perpendicular to the line x plus 2y minus 4 equals 0. So these two lines intersect at F. Find the coordinates of F. So again, this is similar with our example a while ago, wherein you have two lines. Okay, so the first line, it has point A. All right, and then the second line, they gave you the equation of the straight line. So it is x plus 2y minus 4 equals 0. And then these two lines are perpendicular, so they create a 90-degree angle. And then these two lines also meet at point F. So here, so this is point F. So your question here is, how would you determine the coordinates of point F? So of course, if you have two lines that are intersecting, the only way that you can answer this is by solving them simultaneously, right? Now, what you need is the equation of line AF. This one, this line here. You need its equation in order for you to solve the coordinates of point F, right? So right from the get-go, I'm going to get the equation of line AF. Now, but how do I get there? How do I get the gradient? How do I get the points that I need to get the equation of the line? See, class, everything that we've learned is now connected into one question, right? Gradients, points, equations of a line, everything is now in this question. So from here, I'm going to get the gradient of my second line, or line AF, from this equation, because yeah. But the problem here is I need to rearrange this first, because I cannot determine the gradient written in this way. It should be in the format of y equals mx plus c, right? I need to find the m. Okay, so from here, I'm going to rearrange this, make y the subject. So it becomes what? It becomes this. It becomes y equals negative 1/2 plus 2. Is that clear? Of course, you need to get rid of 2. So you need to divide both sides by 2. So negative x over 2 is simply negative 1/2 x. And then 4 divided by 2 is 2. So with that, this is now the equation of this line written in y equals mx plus c format. Now, from here, I know that negative 1/2 is the gradient of the line, all right? Okay, of the other line, okay? So, from here, how do I get or how do I determine the gradient of the other line or line AF? Right, you remember I have two lines, and then this line has the x plus 2y minus 4. So how do I determine the gradient of line AF? So by, again, applying this concept here, negative reciprocal, because they are perpendicular to each other. Therefore, the gradient of line or the first line is a negative reciprocal of the gradient of the other line. All right. So if the gradient of line x plus 2y minus 4 is negative 1/2, the line perpendicular to it has 2, right, as its gradient. Again, they are negative reciprocal of each other. All right, it only applies to perpendicular lines. So again, the gradient of line AF is 2. The gradient of line x plus 2y is negative 1/2. All right, so that's the relationship between the gradient of perpendicular lines. Remember this class because this one always appears during examinations and tests. Okay, so yeah. Now, how do we check if we're correct? Again, you just multiply the gradient of the first and then the gradient of the second line, and then your answer should be negative 1. Obviously, if you multiply negative 1/2 and 2, you'll get negative 1. So we are correct. Okay, so the gradient of line AF is 2. There you go. Now, can I find the equation of the line AF? Yes. Using this formula, I have now my gradient. I have my x and y value from point A, right? So from there, I can now solve and get the equation of line AF. So substituting everything here, so I'll get y minus 5 equals 2 times x minus 4. And then simplifying everything, this is now my equation. Y equals 2x minus 3. Now, your second equation now, or your second line, has now an equation. So the first line is x plus 2y minus 4 equals 0. The second line now is y equals 2x plus 3. All right, so we now have equations for each line. Any question, class? All right, none. Okay, now the question is not over with those two, right? The question is their intersection point because those two lines intersect at point F. So again, how do we find for their intersection point? We solve them simultaneously. It's up to you if you want elimination or substitution. But for me, I use substitution here. Okay, so here are my two equations. Again, this and this, right? So what I did here is I began with this, x plus 2y minus 4 equals 0. And since y is equal to 2x minus 3, I'm going to substitute y or 2x minus 3 to this equation. That's why your y now is now 2x minus 3. It came from here. So this is substitution. Now from here, just solve for x. So you know the basic stuff, right? Okay, so you just solve everything. X is equal to 2. There you go. Okay, and then for the y value of point F, so you just use this, then substitute the value of x, which is 2, you'll get y equals 1. So therefore, the coordinates of point F is 2, 1, or 2 comma 1. All right, so that's it. That's your answer for number 5.